This is lesson 3-2, solving multi-step equations. So we've passed up the two-step, and now it is a multi-step equation that we are trying to solve. But our mission is still the same. Get the variable alone. We want to get, in this case, A alone. Well, before we can do that, we've got to get all of our A's together. Notice they're separated, and they need to be all in one. They need to be all together. So the first thing we're going to do here is combine like terms. 3A plus another A, you can think of it like 3 apples and another apple makes a total of 4 apples. So we combined 3A plus A and got 4A. What's left on the left side? Plus 6, and bring down our equals 90. Now this is just like those that we solved in 3-1. So we start by undoing addition or subtraction. So the opposite of adding 6 would be to subtract 6 from both sides. Make sure we always do it to both sides. This is the subtraction property of equality. Bring down 4A, we didn't do anything to it. Plus 6 minus 6, they're additive inverses. Bring down the equals. 90 minus 6 is 84. And finally, the opposite of multiplying by 4 would be to divide both sides by 4. 4 divided by 4 is 1. 1 times A is simply A equals 84 divided by 4 is 21. You can do that off to the side if you'd like. And our answer is 21. Remember that you can always plug it back in to your original equation to make sure that you got it correct. Let's try a few more. Solve each equation and check your answer. So again, we have these like terms that we can combine. If we're going to solve for x, then all our x's need to be together first. So what's 3x minus 4x? Well, remember you can change subtraction to adding the opposite. So 3x and negative 4x gives us a negative 1x, or just a negative x, plus 6 equals negative 2. And we undo addition and subtraction first. The opposite of adding 6 is to subtract 6 from both sides. We always do it to both sides. Bring down your negative x plus 6 minus 6, additive inverses. Bring down your equals. Negative 2 and negative 6, they have the same sign, so add and keep the sign, negative 8. Remember, though, we're not finished here because we can't have a negative variable. We need to know what x is. So we can either multiply both sides by a negative 1 or divide both sides by a negative 1. And I'll go ahead and just divide both sides by a negative 1. A negative divided by a negative is a positive. Anything divided by 1 is just itself. X equals negative 8 divided by negative 1 is a positive 8. And x is 8. So let's check it. So I have 3 times 8, because remember we're plugging in 8 for x, minus 4 times 8 plus 6 equals negative 2. Remember to follow PEMDAS. PEMDAS says multiply first. 3 times 8 is 24, minus 4 times 8 is 32, plus 6 equals negative 2. And we have to work this left to right. 24 minus 32 is negative 8. Remember, it's adding the opposite. 32 minus 24 is 8. 32 is bigger. It's negative. Answer is negative. Plus 6 equals negative 2. Negative 8 plus 6 is negative 2, and negative 2 does equal negative 2. So we found the correct answer. Let's look at B. Again, we have our 4m and a negative 2m. We need all of our m's to be all together before we can solve for them. So I'll combine like terms here. Bring down your 7 equals 4m minus 2m's would leave us with 2m plus 1. And now we undo addition subtraction. So opposite of adding 1 would be to subtract 1 from both sides. 7 minus 1 is 6. Bring down your equal sign. Bring down your 2m. Plus 1 minus 1 cancels. Our additive inverses. The opposite of multiplying by 2 would be to divide both sides by 2. 6 divided by 2 is 3 equals 2 divided by 2 is 1. Times m is just m. It's the identity property of multiplication. And now we need to substitute it. So I have 7 equals 4 times m is 3 minus n, m is 3 plus 1. We follow PEMDAS. Bring down your 7. 4 times 3 is 12 minus 2 times 3 is 6 plus 1. So 7 equals, work left to right. 12 minus 6 is 6 plus 1. And 7 does equal 6 plus 1 is 7. So we did it correctly. All right, 2 more on this example. Again, we have this negative 2y and a positive 5y. We need to get all our y's together before we can start solving for y. So negative 2y and a positive 5y, 5 minus 2. They have different signs, one positive, one negative. So we have to subtract. 5 minus 2 is 3y, and keep the sign of the larger digit, which is 5, plus 5 equals 14. And now it just becomes a two-step problem. The opposite of adding is to subtract. Bring down your 3y, bring down your equals. 14 minus 5 is 9. And the opposite of multiplying is to divide both sides by 3. So y equals 3. You can again, of course, check by plugging in 3 for y. Let's look at D. So same thing. We have negative 3z and negative 2z. We have to get all of our z's together before we can solve. Negative 3z and negative 2z, they have the same sign, so we add and keep the sign. 3 and 2 is 5, so negative 5z. What else is left? Plus 8 equals negative 12. The opposite of adding 8 is to subtract 8 from both sides. That cancels. Bring down your negative 5z. Bring down your equal sign. Negative 12 minus 8 is negative 20. The opposite of negative 5 times z is to divide both sides by negative 5. So that z equals negative divided by negative is a positive. 20 divided by 5 is 4. Z equals 4. Example 2. You need to build a rectangular pen in your backyard for your dog. One side of the pen will be against the house. Two sides of the pen have a length of x feet, and the width will be 25 feet. What is the greatest length the pen can be if you have 63 feet of fencing? So what I like to do in this, in cases like these, is to go ahead and draw a picture since they didn't give me one. It says that one side of the pen will be against the house. So I'm going to make this my house back here. Two sides of the pen have a length of x feet. So since this is out, the only two sides that could have the same length would be this side and this side, x feet and x feet. And the width will be 25 feet. So that must be this right here, 25 feet. What is the greatest length the pen can be if you have 63 feet of fencing? So they're asking, what is this x going to be? What's the greatest length it can have if your total is 63 feet? So I know that all of my fencing has to add up to 63. It can't be more than 63. It has to add up to 63. So you know, if we're talking about fencing, then we're talking about perimeter. How do you find the perimeter of any shape? You just add all the sides. So I'm going to add x plus 25. And that has to equal 63 because that's the total amount of fencing I have. Like we've been doing, we're going to combine like terms first. If we're going to solve for x, we need to have all our x's together. So x plus x is 2x plus 25 equals 63. And then undo the addition by subtracting 25 from both sides. So I have 2x equals 63 minus 25. 60 minus, well, and we can just borrow from the 6, make it a 5. 13 minus 5 is 8. 5 minus 2 is 3. So 2x equals 38. And finally, the opposite of multiplying by 2 is dividing both sides by 2, so x equals 19 feet. So what's the greatest length the pen can be? 19 feet. This was 19 and this is 19. That's 38 plus 25 gives me 63. Of course, these could be shorter if I felt like it. I could make them both 10 or both 15. Then I would just have some extra fencing. Let's look at example 3. Notice now we have these parentheses. And we need to solve for x. Can I do anything with x minus 3? No, I've got to first distribute. So we need to distribute the 2 to both things inside to get rid of our parentheses. 2 times x is 2x. 2 times negative 3, negative 6, equals 8. And now we solve like any other problem. The opposite of subtracting 6 is to add 6 to both sides. Bring down your 2x equals 8 plus 6 is 14. The opposite of multiplying by 2 is to divide both sides by 2. And x equals 7. You can then, of course, substitute to check. So I have 2 times the quantity, x is 7, minus 3 equals 8. You can either use the distributive property or follow PEMDAS. Let's try PEMDAS. So I have 2 times the quantity, 7 minus 3 is 4, equals 8. 2 times 4 is 8, and that equals 8. So we did it correctly. Let's try a couple more of these. Again, we have to distribute first. So 3 times k is 3k. 3 times 8 is plus 24 equals 21. Then we have to do the opposite of adding 24, which is to subtract 24 from both sides. So we end up with 3k equals 21 minus 24. So the negative number is bigger, so we end up with a negative 3. Divide both sides by 3. And k equals negative 3 divided by 3 is a negative 1. Again, you can substitute to see that it's correct. Negative 1 plus 8 is 7 times 3 is 21, which is what the right side is. So let's look at B. Again, we have to distribute first, or I'll bring down my 15 first, and my equals. Negative 3 times x is negative 3x. Negative 3 times negative 1 is plus 3 plus 9. But now look, we can still combine like terms before we do anything else. Make sure that your equation's in simplest form before you start adding things to both sides and subtracting things from both sides, multiplying and dividing. Make sure it's in simplest form first so we can combine like terms before we do all that adding and subtracting. So bring down the 15 equals, bring down the negative 3x. 3 plus 9 is 12, so plus 12. And now it just becomes a simple two-step equation. So we start by undoing addition, subtract 12 from both sides. 15 minus 12 is 3. Bring down your equals. Bring down the negative 3x plus 12 minus 12 cancels. The opposite of negative 3 times x is to divide both sides by negative 3. 3 divided by negative 3, a positive divided by negative, gives us a negative. 3 divided by 3 is 1. Negative 1 equals, and those cancel, x. Okay, let's look at example 4. In example 4, we come to our fractions. And I know how most people feel about fractions, but remember, fractions are your friend. They make solving easier. So in this example, we're going to learn 2 different methods for solving equations with fractions in them. In method 1, that's what we'll do first. We're going to just add our fractions together. So we're going to start by finding the common denominator for all of our fractions, the least common denominator. And the least common denominator for 2 and 5 is 10. So I'm going to change both these fractions to something over 10. So what did I do to 2 to get 10? Times 5. So 3 times 5 is 15. X, don't forget your x. Over here I multiplied 5 times 2. So remember that there's this imaginary 1 in front of your x. There's an imaginary 1 in front of all your variables that don't have coefficients. So I have to multiply 1 times 2 as well, which gives me 2x. And now we can add our fractions together. 15x tenths plus 2x tenths. 15x plus 2x, remember, just add the numerators, keep the denominator the same. 15x plus 2x is 17x. Divided by, leave your denominator, equals 17. Now we just have a fraction times our variable. Remember that to get rid of a fraction times the variable, we multiply by the reciprocal because we can't divide fractions. We end up multiplying the reciprocal anyway. So notice the 10s cross cancel and the 17s cross cancel, so we're left with x equals. And this is 17 over 1, so again, your 17s cross cancel. 17 divided by 17 is 1. 17 divided by 17 is 1. 1 times 10 is just 10. So x is 10. That's one way to solve it. Let's look at method 2 now. The other method is to, again, let me rewrite the original. 3 has x plus x divided by 5 equals 17. The other method is my personal favorite. It's where you multiply to clear fractions. You still have to find the common denominator first. So again, the least common denominator for 2 and 5 is 10. But instead of getting a common denominator for both your fractions, you just multiply everything by 10. And remember that we can do whatever we want to both sides of our equation as long as we do it to both sides. So I'm going to multiply both sides times 10. This is 10 over 1. I'm going to show you the long way first, but then I'll tell you which step I would skip. So this is 10 times 3x is 30x, divided by 1 times 2 is 2. And notice I put parentheses around this whole thing. Every single thing in your equation has to be multiplied by 10 or it's not fair. So I put parentheses around this to say I'm going to multiply 10 times my first term and 10 times my second term. So I have 10 times x, which is 10x, divided by 1 times 5, 5, equals 17 times 10, 170. So again, let me point out that everything was multiplied by the least common denominator. Now watch what happens here. 30 divided by 2 is 15, so 15x plus 10 divided by 5 is 2x equals 170. Now I can combine like terms. 15x plus 2x is 17x equals 170. And the opposite of multiplying by 17 would be to divide both sides by 17. So x equals 10 again. So see, we got the exact same answer no matter which method we use. Now this is the step I would usually skip right here. Instead of doing that, I would cross cancel in my head. So I'd cross cancel the 10 and the 2. They're both divisible by 2. I do this part in red. 2 divided by 2 is 1. And in my mind, I'm thinking 10 divided by 2 is 5. 5 times 3x is 15x. And then I'd cross cancel with my other fraction. The 10 and the 5 are both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So 2x. Notice I don't touch this fraction because I have to use it both times for both terms. And again, be very careful that you are distributing whenever you multiply by the least common denominator. This is called multiplying to clear fractions. And again, that's the method I prefer. Let's look at quick check for A and B. Again, I'll show you both methods. So again, we have to look at all of our fractions. So I'll do method 1 first, which is just getting a least common denominator for all of our fractions. So the least common denominator for all these would be 8, which means we're leaving this fraction alone. But on my first fraction, to get 8, I had to multiply times 2. Remember, there's an imaginary 1 here. 1 times 2 would give me 2, so 2m. Same thing here, imaginary 1. 2 times 4 would give me 8. 1 times 4 gives me 4m. And then we combine like terms. 2m and 4m gives me 6m divided by 8 equals 5/8. Remember that we got common denominators here so that we could add our fractions together. And then we have a fraction times our variable. So we have to multiply by the reciprocal. Remember, this is a special case. Even though it's multiplication, we still multiply to undo it. And then we can cross cancel. The 8's cross cancel and the 6's cross cancel. I'm left with m equal. Here the 8's cross cancel and they both become 1. 8 divided by 8 is 1. 8 divided by 8 is 1. So I'm left with 5 times 1 and 1 times 6. 5 times 1 is 5. 1 times 6 is 6. So m is 5/6. Let's try it with method 2. So I'll start with my original, m divided by 4 plus m divided by 2 equals 5/8. Start by finding the least common denominator for all fractions. The least common denominator for all fractions is, again, 8. And then you have to multiply every single term by 8. So I have to put parentheses around the whole left side and parentheses around the right side to make sure everything gets multiplied by 8. Then we distribute 8 times m4. So remember, this is 8 over 1. Change this to 8 over 1 as well. And I would, again, cross cancel. You don't have to if that step's too hard. So I'll show you the step without cross canceling. 8 times m is 8m. 1 times 4 is 4 plus, distribute the 8 times the other fraction. 8 times m is 8m. Divided by 1 times 2 is 2 equals 5 times 8 is 40. Divided by 8 times 1 is 8. So again, we could have cross-canceled all these fractions, and we get the same thing that we're about to get. So let me show you cross-canceling what we would have gotten. 8 and 4 are both divisible by 4. 4 divided by 4 is 1. And then 8 divided by 4 is 2. So 2 times m is 2m plus, cross-canceling here, divide 2 and 8 both by 2. 8 divided by 2 is 4. 4 times m is 4m equals, cross-canceling here, 8 and 8. 8 divided by 8 is 1. 8 divided by 8 is 1. 5 times 1 is just 5. And let's see when we simplify these if we don't get the same thing. 8 divided by 4, 2. 2m. 8 divided by 2, 4. 4m. and 40 divided by 8 is 5. So notice that you'll just cross cancel, you'll get the exact same thing as working it the long way, and it's much shorter. You can skip this step. Now we just need to combine like terms. 2m plus 4m is 6m equals 5. And then the opposite of multiplying by 6 is to divide both sides by 6, so m equals 5, 6, and there's nothing we can do with that fraction. Let's look at B. Here, it's up to you what method you want to use. You have to use the least common denominator no matter what. So the least common denominator for 3 and 8 is 24. And I'll just show you method 2. So we multiply both sides times 24. And remember that you have to distribute. And I'm going to just do the cross-canceling this time. So 24 and 3, we can cross-cancel by 3. 3 divided by 3 is 1. 24 divided by 3 is 8. Times 2 is 16x. And then we have to multiply 24 times negative 5/8. So positive times a negative gives me a negative. And cross-canceling again, divide 24 and 8 both by 8. 8 divided by 8 is 1. 24 divided by 8 is 3. Times 5 is 15x equals 26 times 24. 4 times 6 is 24. Carry the 2. 4 times 2 is 8, 9, 10. 0. 2 times 6 is 12. Carry the 1. 2 times 2 is 4. Plus 1 is 5. Bring down the 4. 2. 624. 16x minus 15x is just 1x left over, which is just x, equals 624. And there's your answer. Okay, last example, example 5, is all about clearing decimals. And clearing decimals is actually easier than clearing fractions. There's really just one way to do it. Read out your fractions. 6/10 A, 18 and 65 hundredths, 22 and 85 hundredths, because you're going to multiply everything by the largest place value. So here the largest is hundredths, which means I'm going to multiply everything by 100. Both sides, every single term has to be multiplied by 100 to keep it fair. So again, here we go with our distributing. 100 times 6/10. Remember that the 100, it just tells you to move the decimal 2 places. There are 2 zeros, so move your decimal 2 places. And in that empty space, fill in a 0. So now I have 60A plus, again, move it 2 places, 1,865 equals, and move it 2 places, 2,285. So multiplying by 100 just moves your decimal 2 places. And you can see that if you go off to the side and multiply by 100. Because the first thing you do is write down those 2 zeros, and then 1 times 5 is 5, 1 times 8 is 8, 1 times 2 is 2, 1 times 2 is 2. There are 2 numbers behind the decimal, 2 numbers behind the decimal, and notice what we've done. We've moved it 2 places to the end of the number. That's all you're doing. When you multiply by 100, you move it 2 places. It's the same number of zeros that you have. And now we solve it like any other equation. So we start by adding or subtracting. We always undo addition or subtraction first. Bring down your 60A equals 5 minus 5 is 0, 8 minus 6 is 2. Can't take 8 from 2, so borrow from the 2, it becomes a 1. 12 minus 8 is 4. 1 minus 1 is 0. And then the opposite of multiplying by 60 is to divide both sides by 60. So A equals, you can cancel the zeros, 42 divided by 6 is 7. And of course, you can always substitute to check your answers. Alright, last 2 problems for this lesson. So it's, again, read out your decimals to figure out what you're multiplying by. So this is your tenth, hundredth, thousandth place, 25,000. Tenth, hundredths, 25 and 95 hundredths, 23 and 65 hundredths. So what was the largest one? The thousandth place, which means you have to multiply every single thing by 1,000. You have to be fair. You have to do the exact same thing on both sides. Every term has to be multiplied by 1,000. So we have to use the distributive property. 1,000 times 25,000. Move it 1, 2, 3 places. So 25x plus 1, 2, 3 places. Empty seat gets a 0. 2,000 or 22,950 equals 1, 2, 3 places, empty seat gets a 0, 23,650. And then we solve like all our other problems. So add or subtract first, undo addition or subtraction. So subtract 22,950 from both sides. That cancels. Bring down your 25x equals 0 minus 0 is 0, 5 minus 5 is 0, can't take 9 from 6, borrow from the 3, it becomes a 2, 16 minus 9 is 7, 700, and then we divide both sides by 25, so x equals 28. 700 divided by 25 is 28. Last one, read them out to figure out what to multiply by. 1 and 2 tenths x, 3 and 6 tenths, 3 tenths, 2 and 4 tenths. So everything's the tenth place. I'm just going to multiply every single term by 10. And again, we have to use the distributive property because every single thing has to be multiplied by 10. So move the decimal one place in all of your terms, every single term. This becomes 12x minus 36 plus 3x equals 24. Should be no decimals left in your equation. Now this becomes like earlier in the lesson where we had to combine like terms. So I have 12x and 3x. We have to get all our x's together first before we can solve. 12x and 3x gives me 15x minus 36 equals 24. And we always undo addition subtraction first, so add 36 to both sides. 15x equals 20 plus 30 is 50, 4 plus 6 is 10 to 60. Divide both sides by 15, and x equals 4. See how a problem that looks so complicated can end up so simply. And before I let you go, let's look at these steps that we've been doing. So step 1, clear fractions and decimals. Obviously, this only applies if there are fractions or decimals. 2, use the distributive property. Again, this only applies if you have parentheses in your problem and you need to distribute. 3, combine any like terms. That's what we were just doing here when we did 12x and 3x. That's combining like terms. Then undo addition and subtraction, and finally undo multiplication and division. Remember, you always undo addition and subtraction before multiplication and division. All right, that's lesson 3-2. Good luck.